Hey everybody, in this video I'm going to give a quick introduction to matrices. So a matrix is a rectangular arrangement of numbers called entries of the matrix. We denote them by enclosing the entries between a left bracket and a right bracket, and we name them using capital letters. So we can see, we say this as matrix A equals, and then we write out what the entries are. Matrix A has 2 rows, 1, 2, and 3 columns, 1, 2, 3. So we say matrix A is a 2 by 3 matrix. Okay. And then matrix B has 3 rows and 3 columns. So we say matrix B is a 3 by 3 matrix. Matrices occur in many different sizes as defined by the numbers of rows and columns. So we represented that for A as the 2 by 3 and B as the 3 by 3. Matrix B in the last slide was what's called a square matrix because a square matrix has the same number of rows and columns. So here we have a square matrix. Another quick definition is diagonal entries. The diagonal entries are the values on the diagonal line from the upper left to the lower right. So this diagonal is referred to as the diagonal entries. So for this matrix, we would have 2, 6, and -1 in our diagonal entries. When we refer to matrices, we often categorize them by order. Order is the size of the matrix. So when we have these matrices given, so sometimes we might see a matrix with parentheses around it or square brackets. They're still valid ways. We go row by column. So this first matrix has 2 rows and 3 columns. So we say it's a 2 by 3. This matrix here has 2 rows and 2 columns. So it is a 2 by 2, which happens to be a square matrix because it has the same number of rows and columns. Here we have 2 rows and 1 column. So that is a 2 by 1. Here we have 3 rows and 2 columns, so it's a 3 by 2. For this one here, we have 2 rows and 3 columns, so this is another 2 by 3. So they have the same, that one has the same order as this 2 by 3 up here. And then this last one has 3 rows and 3 columns, so it's a 3 by 3, which is also a square matrix. When we're talking about matrices, 2 matrices are equal if and only if the corresponding entries are equal. So if we're told that matrix A equals matrix B, that means that all of the entries have to be equal. Now we want to find the values of A, B, C. B is in this first row and first column of matrix B. And since matrix A and matrix B are equal, that means this first entry for both matrices has to be equal. So 1 has to equal 1 plus B. Or B must be equal to 0. Okay, so we found what B was. Now look at C. That entry corresponds to this entry here in matrix A, which is entry 2, and since the matrices are equal, C must be 2. For the last one, A is in the same entry spot as -10, so A must equal -10. So again, 2 matrices are equal if and only if corresponding entries are equal.